Hello, hello again to all the fellow geeks out there in the podcasting world. This is our third and final segment for our June episode, all about technology. Again, I'm sorry, but our fellow friend Matt couldn't be with us here today. And we are talking about things technology related. We've talked about artificial intelligence. We've talked a little bit about hacking. Now we're going to talk a little bit about privacy and encryption in our modern world. Like with the other episodes, we're going to talk a little bit about fact versus fiction. What is real in the world of privacy and encryption, and what is kind of made up in the world of fiction. And the first movie that I want to talk about is one that came out in 2001, and it's called Swordfish. And you might think, well, Swordfish, that I watched that. That was a hacking movie, right? Why is it in the encryption? Well, what's interesting about Swordfish, as we've moved with the hacking episode, we talked about coming out of the 80s and people were just easily accessing people's machines via modems, and it was a fairly simplistic world where people had very easy passwords. As we get into the 2000s, people are starting to learn some lessons. They're like, we need to protect this data. We need to keep it safe. And how do we do that? We need to have strong passwords and we need to encrypt our data. So what's that mean? We need to encrypt our data. We need to store our data in a way that if somebody were to steal it without the proper credentials, they would be unable to decipher its meaning. And we came out with algorithms that would do that would basically encrypt the data in a way that it couldn't be seen. And one of the algorithms happens to be called blowfish. So the swordfish is just another type of fish. But when you first think of it, if you know of the algorithm blowfish, then you might think, okay, that's what he's getting at here. It's an encryption technique that actually came out in 1993. I don't know, was the name came out before the movie Swordfish, which I think came out in 2001, but very simple. Blowfish is a real actual algorithm used to encrypt data, and Swordfish was the movie about a hacker trying to hack into people. Now it's more complicated than it used to be. Now your data is encrypted. How are you going to get past that encryption to get at that data to be able to implant the computer virus into the system? So Swordfish, Blowfish, kind of an interesting mix of the real versus the fictional world. Another movie I want to talk about is the Da Vinci Code. The Da Vinci Code doesn't really have any computer hacking in it, doesn't really mention computers. But what's interesting, if you watch the Da Vinci Code, is there is a lot of puzzles being solved. And it brings forth the idea that this idea of encrypting data has been around since long before computers even existed. Back in the time of Caesar, trying to send messages out to troops, he invented ciphers, ways of encoding his messages so that when they were sent out, that there was nobody, or if somebody tried to intercept it, they would have a challenging or a difficult time trying to figure out what that meant. And fast forward a little bit to the time of the World Wars, and the Germans invented a machine called the Enigma machine, which was basically a very souped up typewriter that you would type your message into. But as you typed letters on that keyboard, different letters than what you typed would appear on your printout. You would take that printout, you would type those letters into the receiving Enigma machine as you see them on the screen, and it would produce the actual message. So again, not a computer, but a mechanical technology using a typewriter and a series of plugs that would encrypt and decrypt the data that the Germans would send messages across throughout the entire war. And I mentioned the great founder of artificial intelligence, Alan Turing, who came up with the idea of the Turing test. He was also instrumental in these war times of figuring out how to crack the Enigma machine, because it was a very complex ciphering method for storing data, and he was a very prominent mathematician of the day, trying to come up with ways to try to figure out how to hack this machine. And of course, they made a whole movie about it called The Imitation Game. Definitely worth watching. Definitely showing some of the factual references along what he went through. and what his team went through to try to figure out how do we gain access to this, and then some of the horrible decisions they had to make once they actually did figure out how to decrypt the machine, to maintain security, even in some cases at the loss of many lives. So a good movie, and technically what he invented to determine how to crack the machine, the device that he creates, very mechanical, but very close to what we would think of in a high level sense as a high level computer, in a high level sense that we would think of as a computer. So very interesting. Now, the other reason I mentioned the Da Vinci Code, if you haven't watched it, go check it out, is the same author, Dan Brown, who wrote the Da Vinci Code as a book, also wrote another book called Digital Fortress, one of my all-time favorite books, definitely in the top 10 list. And Digital Fortress is about computers and hacking into computers, and it talks about the FBI, and it talks about some of the algorithms that they use. The main core concept in this book is the idea of an algorithm which basically, if you own it, can defeat. It's sort of this amazing encryption system that can defeat the NSA's top machine, and make sure that even it can't secretly decrypt your data. And it's a very interesting plot. It's a very interesting story. I don't think it's ever been released again as a movie. It would definitely make a really amazing movie to watch. Actually, maybe they did, but maybe it didn't turn out. You can look into that yourself. But it's called Digital Fortress. You can get it on Audible if you just want to listen to it as an audiobook. A really amazing story about this sort of hacking world, this sort of encryption world, and the fictionalized idea of the depths that the government will go to keep their data safe, basically by being able to snoop on everybody else. And I find that there's some correlations in that story, and in the true life story of Edward Snowden, who revealed a lot of information about the way government surveillance works that probably he wasn't supposed to. He was a bit of a whistleblower in that way. And so, yeah, imitating fact versus fiction. The real life situation was, probably around 2013, and the book came out many years before that. So it's just kind of an interesting relationship there. So let's talk a little bit about encryption and what is real versus the fiction. So it is true that we've grown a lot significantly in how we manage our data and how we encrypt our data, how companies store and save our data using all kinds of various encryption techniques. One of the first ones in the 70s was called DES. And it was the initial encryption standard that was adopted by the government to protect our data, digital encryption security. As computers came faster, just as I said was predicted by Ray Kurzweil, machines become faster and faster and faster, which means they can hack these encryption algorithms. They can figure them out without the password faster and faster and faster. DES encryption was eventually broke not too long after it came out. So then they came up with triple DES called 3 DES encryption, which basically meant they encrypted the same thing with the same algorithm, only they did it 3 times. Again, computer technology gets faster and faster and faster, causing 3DES to actually eventually become broken as well. So as developers, we have to keep coming out with new, stronger algorithms to beat the fact that the computers get faster and faster, and the time that it takes to discover the password or discover and decipher the test becomes faster and faster. Right now, the one that we're using is called the AES, the Advanced Encryption Standard, which is better than 3DES, which, unless the government has secretly figured out how to hack it, as far as we know, it cannot be hacked. And it was actually sort of in competition with that blowfish algorithm. There was a bunch of series of algorithms generated around the same time, almost like a little contest. Actually, I think it might have been a contest to be like, what will be the next encryption standard that comes out? And the one that won wasn't called AES at first, but it eventually got renamed as AES, the Advanced Encryption Standard, and that's what's used to protect most data today. And these systems like 3DES and DES and AES, fall under a category of what we call shared key password encryption. So if you know the password that encrypted the data, you can use that same password to decrypt the data. So a lot of attempts to actually gain access to this data is to try what's called a brute force attack, to try a dictionary attack, to try multiple different types of passwords to see if we can get the system to return back to us some real data that makes sense to us. A second type of encryption is known as PKI, public key encryption, and it differs mathematically in the sense that there's two keys, one key that encrypts the data and a different key that decrypts the data. So knowing the encryption key does not give you the ability to decrypt the data. And knowing the decryption key does not give you the ability to re-encrypt the data. And this public key infrastructure, it is what is used when you're doing your banking transactions online, when you're logging in with your credit card. In fact, recently the entire internet has switched pretty much to HTTPS, which again is using this public key encryption. When you go to a site and you see that little S, HTTPS, the data is getting encrypted on both sides, one side encrypting it with its key, the other side decrypting it with its key, back and forth. And actually, if you wanted to get into the real technical details of it, that only happens very quickly at the beginning so that they can share a key between them and say, okay, this is the key we both agree on to use for the encryption, and then it uses this AES encryption after that to actually shared key encryption to send the data. And the first part is just the initial handshake with public key encryption to figure out what that shared key is going to be. And that's how a lot of it works. I'm going to show you about some of this public key encryption using a very simple tool. I'm going to walk you guys through it, and you can use it yourself to create your secret messages that you want to send to other people. In my opinion, it doesn't get used nearly as often as it should be. From a privacy perspective, we talked in the hacking world, we talked about how people are trying to steal your data. They're trying to steal information from you, and they're trying to use it to basically force you to give them money, whether that be through some sort of evasive methods. But the other part that I wanted to talk about in this episode is the idea of privacy, is the idea that simply being on the internet, simply by interacting with some of your favorite social media tools, you're giving a lot of information about yourself to the companies that are hosting this data. And they're not necessarily using it to try to extort you. They're using it to sell your information to other people because that's the model of how they make money. So you go onto these tools and they're free, right? You don't pay a monthly fee to use your Snapchats or to use your Facebook or to use your, what's the one recently everybody's trying to put a ban on? TikTok, everybody's trying to put a ban on because the idea that they're trying to steal your information. Again, not to extort you, but because they can then sell that information to advertisers because that's the model of how they make money. And there's some very simple things that you can do to keep that information private, to keep that information from getting out there, to keep that information from being used against you. But a lot of people just, they don't use the tools. They don't try it. They don't install the tools, and so that information just kind of gets absorbed. And because putting all of these three segments together, because of where we've advanced in artificial intelligence, these algorithms are able to take little bits of data that you leak here and there, not even knowingly, and build a complex profile about who you are as a person, as a spender, as a consumerist, and reach conclusions. And a very real, true situation. Again, I'll put an article in the show notes about a father who discovered that his daughter was pregnant thanks to a certain company that started just automatically selling, or I should say, automatically putting in the mail coupons to his daughter for pregnancy type stuff. And what this company had done is they had developed an algorithm that was scanning all of their data they had about people and coming up with a factor to determine the odds that they are pregnant based on the recent purchases that they've made in that store. And then by targeting them through their marketing people with specific coupons for pregnancy related things. So what happens is the father gets very upset, and he writes a stern letter to this company, and he says, why do you keep sending my 16-year-old stuff about pregnancy, coupons about pregnancy, coupons about diapers? She's only 16. She shouldn't be getting this stuff. Like, I think there's something wrong. And then, he goes back and forth with the company multiple times. The company doesn't know what's going on either. They're apologizing. They're like, we're sorry that this information got sent out to your daughter. And he eventually responds. He's like, actually, I need to say that I'm sorry to you. My daughter and I had a long talk last night. It turns out that she actually is pregnant and was scared to tell us about it. So the company accurately predicted the 16-year-old daughter's pregnancy simply by some of her prior purchases. Maybe, for example, she bought some special vitamins that you take during your pregnancy. But it did some calculations, and it gave her a high probability of being pregnant, and then correctly targeted her with coupons for, say, diapers and baby clothes and stuff like that. And the father was like, wow. So that information can be fed into these artificial intelligence, again, weak AI algorithms, and get accurate information out about the assumptions that it made based on that information. Okay, so I want to talk to you about 3 very easy to use tools for your encryption and your privacy purposes. These tools are 100% completely free and open source. They're very easy to use. I don't think they get used enough. So I'm going to promote them out there, and I'll have individual videos for each one showing how each one can be used. If you're listening to this on the audio version of the podcast, I'll encourage you to go out to those videos in the description, in the show notes, and you can go watch the videos of how they work. The first is called GPG for USB. This is a very simple tool that you download, and you basically use like a notepad document. You type whatever message you want into it, whatever information you want to send an email to your friend, whatever, you type that information in. And you basically simply hit an encrypt button. It's going to use that public key infrastructure, not a shared private key between the two parties, but actually your own key to encrypt. And the receiver is going to have their own key to decrypt back and forth the data. And the video will show you how to do all of this, but it's very simple, very easy to use. And it can be stored on any machine. It will work on any operating system like Windows or like Macs or Linux. It's very simple to use. You download it, and you can easily make that encryption copy of your data. You can then put it in your email, send it to people, and nobody else is going to be able to read it except the person who has your public key so that they can decrypt it and read it, or you encrypt it with their private key, with their public key. You encrypt it with their public key so only their private key can decrypt it. And that's basically how that works. The second app that I highly recommend is called DuckDuckGo. DuckDuckGo is a competitor basically to Google, the Google search engine. And when Google first came out, one of its main mission statements, one of its main code of ethics statements was do no evil. And several years back, they actually removed do no evil from their from their mandate, from their code. It's no longer there as part of Google, and it kind of makes you wonder, why did they remove this amazing do no evil? Well, DuckDuckGo is a search engine, but it's much more, and it promises absolutely no tracking of any of your searches in any way. DuckDuckGo is also available as a mobile client that you can install. Their mobile client has some very interesting features as well that you can enable. Some are still in beta, but basically will also keep track of all your other apps and prevent those other apps from leaking private data and information as well. So DuckDuckGo, another excellent tool, very easy to go to download and install. It's basically a plugin for your Chrome browser or for your Edge browser. It's a little app that you install on your mobile phone. Switch your searches from using Google to using DuckDuckGo to get increased privacy, really good search results high quality, excellent search engine, and all the privacy features that it includes on top of that. The third tool is not for necessarily encrypting messages back and forth with emails, but it is for your messaging stuff. So maybe you like to use Facebook Messenger for your chat, or whatever type of chat app you like to use. I'm going to suggest switching to one called Signal Messenger. Again, it's 100% free. It does chat messaging back and forth. It does voice calls back and forth. It does video back and forth. And what it does is it automatically encrypts the data back and forth between you and the party or parties. You can do group chats that you're chatting with, and nobody except those people can in any way access your data. If they try to intercept your data in between, they're just going to get a bunch of gobbledygook that doesn't make any sense. One thing I will tell you about Signal Messenger is in order to use it, it will know your phone number, and you will see the phone number of the other people that you're chatting with. So you are sharing your phone number back and forth, and it is using your phone because it's a mobile app, and it's sending that information over your data, or if you're on Wi-Fi, over your Wi-Fi, completely encrypted on both sides, so that only you and the person you're talking to or the group you're talking to is going to see that information, is going to be able to know what it is. Again, 100% completely free. And costs you nothing to use. You just have to download it, install it, share it with your friends, do your messaging on it, and know that nobody is able to tap in and see that information. All these, by the way, are open source as well, so anybody can look at the source, they can look at the security of how it works, meaning that, hey, if you think that we have any errors, that we think that we've did anything wrong with our security, let us know so that we can improve it. So again, highly recommend it. GPG for USB, DuckDuckGo for your web searches, and Signal Messenger for your messaging back and forth. Couple of honorable mentions for your social media. Mastodon is a social networking client, kind of like Twitter, that is focused on privacy and is focused on uh, different a different way of looking at social networking, called the Federated World. And if you do decide to use Mastodon or get into Mastodon, for the mobile app, I would suggest an app called Fedilab. There's many different clients that you can use. Mastodon has its own mobile client, but Fedilab I found to be the best. Also for the mobile, Open Keychain. Open Keychain, again, 100% free. It's basically GPG for USB, except it's so you can use it on your mobile phone as well. And the same keys that you would use for GPG USB can also be imported into Open Keychain and back and forth, so you can use those same keys on those two apps. For email, there's an email app called K9 Mail. It's, again, a mobile app, and it helps integrate that encryption on both sides automatically. So it's a few less steps than, say, having to paste it into one thing, encrypt it, and then paste it into your email. So it'll save you a few steps. But again, uses that same infrastructure called GNU Privacy Guard, which was formerly known as Pretty Good Privacy, PGP. Gives you high grade quality encryption on both ends using this public key infrastructure. So again, both parties have their own keys. They can share their public keys with one another for encryption, and they have their private keys for decryption. Again, go through the videos. There'll be a different video for each one, how each one works, showing some of the details of it, and they'll be released at a later time. But that'll show you how those tools work. GPG, DuckDuckGo, Signal Messenger, those three will greatly improve your privacy. One of the things I've noticed since switching to these is that I still do get ads. You know, Facebook has ads, Twitter has ads, Amazon, I get ads all over the place. But the ads are now no longer have that freaky feeling. And you might have noticed that freaky feeling yourself. If you've ever, for example, just bought something on Amazon and then you start looking through Facebook and for some reason it's selling you the exact product you just bought or something very similar to the exact product that you just bought, or you've gone to Home Depot and then after you've been at Home Depot and you start looking at your Twitter account, you start getting all these ads for different things from Home Depot. Well, that's again because you're leaking a little bit of information, and those artificial intelligence algorithms are building on that to try to recommend you products. Well, since switching to these tools, I still get ads, but the ads don't really have any relevance to me. So This is going to stop the advertising. DuckDuckGo does a little bit block ads, so that's very nice. It just doesn't show you the ad at all when it's integrated. But some of the other things, when you do see ads, they're just really ridiculous ads that make no sense because they're no longer able to see that private information of yours. So that ends segment 3. Again, this entire podcast will be released in its audio format to everybody as one giant dump of technical information. And the individual videos, I think we'll have 3 individual videos released over 3 different days on the YouTube channel, and you can watch all of the different videos in the smaller segment format. But thank you very much for continuing to subscribe to our podcast. If you like what you heard, please let us know. Please share it with others. If you have any questions about this episode or about any episode, or questions on technology or anything geeky, let us know on the appropriate channels, and we will respond and we will do our best. And may the inner geek find you anywhere you are.